This video is an introduction to logarithms. So we'll start with the equation y equals log base b of x. This is how we'll write our logarithm. Notice that there's two variables in this part of it, apart from the y equals. There's the b, which is the base of the logarithm, and the x that is the input or the argument of the logarithm. So now that equation, log base b of x, is equivalent to x equals b to the y. So this logarithmic equation is exactly equivalent to this exponential equation. We are able to convert back and forth between logarithmic form and exponential form, which we'll do some examples of that in a moment. But first I want to point out that our exponential functions were functions in the form y equals b to the x, which is just what we have here, except the x's and y's have been swapped. And since I asked you to review the section on inverses prior to this lesson, I want to point out that when we swap the x's and y's of a function, that's how we get an inverse. So y equals log base b of x is the inverse of y equals b to the x. Now, when you're looking at specific examples, you will have a number for b. So we, in the exponential section, we did an example of y equals 3 to the x. The inverse of that function would be y equals log base 3 of x. We could write that down. For example, or I'll even switch it up. The inverse of y equals 5 to the x is y equals log base 5 of x. Now, when we have inverses, remember the x's and y's are swapped, so the domain and the range are swapped. And the domain of any logarithmic function it's the same as the range of any exponential functions, which you'll remember is all positive numbers. Then the range of any logarithmic function is the same as the domain of any exponential function. The range of the inverse is the same as the domain of the original, and so that is all real numbers. So those are some facts that I'll expect you to know about logarithmic functions. Let's do some examples of converting between exponential form and log form. So I'm going to rewrite at the top the y equals log base b of x is equivalent to x equals b to the y. And I want to convert to exponential form. I have the equation log base k of w plus 2 is equal to 7m. So all I need to do with this equation is convert it into exponential form. So this is logarithmic form. This is exponential form. It is in this form because there is a log, obviously. Notice that k is playing the role of b, and w plus 2 is playing the role of x. That's the input for the log, or the argument of the log. And then the part that is on the other side from the logarithm is 7m, so that is playing the role of y. So when I put it into exponential form, I have x equals b to the y. So the part that was playing the role of x, the input for the log, is w plus 2. That is equal to the base, which is k, to the y, which is 7m. And that is all I need to do for that problem. Now it is in exponential form. We could also go the other way. I want to convert this to logarithmic form. This one is, c to the m minus 3 equals n plus 4. So I have something that's being raised to an exponent. This is in exponential form. Notice that the part that has the exponent is on the left side of the equation instead of the right side, but that's okay. The equations can be reversed. The important things to notice are that c is the base in this exponential form. It is the thing that is being raised to an exponent. So it's playing the role of b. M minus 3 is the exponent, so it's playing the role of y. And n plus 4 is on the other side of the equation, so it's playing the role of x. So if I'm going to write this in the form y equals log base b of x, y is the exponent, so it's the m minus 3 equals log base. C is the thing that is being raised to the exponent, so that is the base. And the x is on the one side by itself in exponential form, and that becomes the input of my log. So that's the n plus 4. So m minus 3 equals log base c of n plus 4. And that is in log form. And that's all I need to do for those. That's just an exercise in converting back and forth. You definitely need to be conversant in that. Now, I'll point out, asking what is log base b of w is the same as asking what exponent do I need to raise b to in order to get w. So I want to find log base 2 of 8. In order to answer this question, I need to ask myself, what exponent do I need to raise 2 to in order to get 8? One way of approaching this that I find helps some people can get straight there just by asking the question, but some people like to say, if If I let n be this logarithm, now I have an equation that I can write in exponential form. When I write this in exponential form, I get 2 to the n equals 8. You could also write that as 8 equals 2 to the n. It's the same thing. But this makes it very clear that I'm raising 2 to a power and getting 8. And the only number that will do that is 3. 2 cubed is 8. Let's do another one. I want to find log base 7 of 1 over 49. So if I write n equals log base 7 of 1 over 49, again, some people are good at asking themselves, what exponent do I need to raise 7 to in order to get 1/49th? But now I have a way of writing it that helps other people. So I need to raise 7 to an exponent. Notice that 7 squared is 49, so that is relevant here, except what I want is the reciprocal of 49, so I need a -2. 7 to the -2 is 1 over 49. And if you need to refresh your memory as to why, rewatch the Solving Exponential Equations video from the last learning module. And I'm going to do one more example along these lines. I want to find log base 5 of the square root of 5. So again, I can rewrite this as n equals log base 5 of the square root of 5. When I rewrite that in exponential form, it'll be 5 to the n equals the square root of 5. And remember, if I need a radical, I need to think about what kind of root this is. That's a square root. And fractional exponents give me roots. This 5 does not have any exponent, so I can think of it as a 1. A square root would be a 2. And so this is 5 to the 1/2 is equal to the square root of 5, and so n is equal to 1/2. And one thing I maybe should emphasize, that means that the log base 5 of square root of 5 is equal to 1/2. Likewise, over here, log base 7 of 1/49th is equal to -2. And over here, log base 2 of 8 is equal to 3. So there are 3 logarithms that we found just based on our knowledge of exponents. That's our introduction to logarithms. You will want to watch the next video on common and natural logarithms.